So my name is Ariane. Good luck with trying to pronounce that. So that's why I go by Chip. And I'm going to try to give you a few ideas on software quality assurance that hopefully will help you put the things into perspective. So when you move from writing code to working in teams that actually develop code, it's going to be easier and you'll understand the process a little better. Excuse the French.
A final decision to go was taken.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage.
Unfortunately, it doesn't take long. So. That's an expensive firework, $7 billion. So on top of those $7 billion, it was carrying a 500 million payload. But that's peanuts at this point. As you would expect, it's a software bug. Well, actually, it's a failure in the quality assurance process. What they were doing because critical safety software is very expensive to develop. They were reusing a subsystem from Ariane 4. And to make the story short, it attempted to convert a 64-bit number to a 16-bit number without checking that 16 bits was sufficient to hold the value. And that caused a runtime error and cascaded into this. So apparently, quality assurance is important. And shockingly, I know. I have a few definitions here. I'm not going to go into this. You have them there. You can read them for yourselves. What I want to emphasize is to satisfy the stated and implied needs, because you can build the perfect car, so you would satisfy the requirements, say, but if it has the steering wheel on the right, it's not going to fulfill the needs in the United States. So the needs of the customer are very important in making sure that you're building a quality product. And and I have a memorable definition for software testing on top of the software quality. It's like petting the cat. You pet it like this first, and then you go against the grain. People use quality assurance and software testing or testing like they are synonymous, and they are not actually. Quality assurance has to do with the processes, and the bottom line, we are trying to prevent bugs from happening with the quality assurance part. Software testing, on the other hand, it's to demonstrate the software is doing what it's supposed to do and what it's not supposed to do. So this illustrates nicely how the quality assurance and testing create the yin and yang of a quality product. Let's take a look at the economics of software testing, where defects originate. Probably, if I asked you this without showing the graph, you'd say in code, right? Well, it's mostly in, a very good part of it's in requirements and design. It's actually almost half of it. And this is a recent study from 2008. Older studies were showing that actually more than half of them were originating in requirements in design. So keep that in mind where we are using the resources for quality assurance. It's mostly in testing. So there is a discrepancy, as you can see, between where they happen and actually where do we put the effort to find them. And the other one is it's pretty well known, the rule. You know about this one. How much it's debatable, but
Really bad if it gets to production.
Yes, exactly. Especially if it's a mass-marketed product. So it's if it's going to be $1 in requirements in design, it's going to cost $10 in code, and then $800 in production. How can we improve quality? And here we need to take a look at different software development lifecycle models, SDLCs. Are you familiar with this? This is the ancient animal, the waterfall model, where, again, I'm not going to go into details today. The idea is that it's very rigid. The activities go one after the other. When one ends, the other one starts. So, and it's very difficult to change requirements, to do any changes in the product while it's already written, coded. A improvement over the waterfall model is the V model, which is a variation of the waterfall model. In the V model, as you can see here, you have on the left side the development activities, on the right slope the testing and debugging activities. And the idea with the V model is that while various development activities take place, the testing phase is prepared. For example, while global design is done, integration tests are prepared. So when time comes to do integration test execution, that's already in place. The problem with the V model is it tends to be even more rigid than the waterfall model, because this is, even if properly done, is very document heavy. It relies heavily on documentation. I think we already mentioned what the problem is. As in waterfall, testing is understood as a one-time action at the end of the project, and it's inflexible, and for waterfall, especially for complex projects, is pretty poor. And give you an example from recent memory, healthcare.gov. It's basically a waterfall project. The front end was developed in Agile, but the rest wasn't. And there are studies that say that about 86% of the waterfall projects fail. And the Department of Defense did an evaluation around the year 2000 of 36 billion worth of Department of Defense projects. And they found out that about 75% were total failures. So you do the math, how much 75% of 36 billion means was code that was never run. If you want to get numbers about how software project fail, check the chaos report on the internet. So the next approach in software development lifecycle is the iterative approach, where The project is broken down into little pieces, and every iteration is building one piece. So this are called increments or builds, and every increment produces a piece of software that's demonstrable, deliverable. That's what I was trying to say. And here there are different names that different methodologies: rapid application development, a rational unified process. This is getting a lot of traction, and I can bet with you now that once you start working, you are at some point you're going to work you're going to be involved in an agile project. You'll be part of an agile team. If you don't, you'll have to change your. This idea of incremental development can be traced back to 1957. So it's nothing new. It's not, and as you can see, this is not nothing rocket science. But in 2001, a group of 17 developers met to discuss lightweight methods, and they came up with this manifesto. Again, in every development project, you'll find individuals and interactions and processes and tools. The thing is that in Agile, the emphasis is shifted from processes and tools, all this traditional approach to development, to individuals, working software, customer collaboration, a more lightweight approach to doing things. And we can spend a lot of time analyzing this. Unfortunately, we don't have that time. So to get a little familiar with the testing, and this is going to help you down the line understanding better what your co-workers, the testing team, is doing. I'm going to tell you a little about the 7 principles of testing. First one is testing shows presence of defects. What that means, but it cannot prove that there are no defects. So it reduces the probability of undiscovered defects, but it's no proof of correctness, unfortunately. Another shocker, exhaustive testing is not possible. I was thinking when I started testing that we can do it 100%. Well, no, because obviously we don't have the time, the resources to cover everything that can and every conceivable test case. Early testing. Testing should start as early as possible in the development life cycle, and that happens with Agile. Defect clustering. This is about the fact that a small number of modules usually produce the most of the defects during pre-release testing. The pesticide paradox. This means that if the same test cases are repeated over and over, no defects will be discovered. So we have to constantly review and revise our test cases. Testing is context dependent. Obviously, it's different how you test a safety critical piece of software or a e-commerce site. And absence of error fallacy is about, it means that a zero defect system does not help if it does not fulfill the user's needs and expectations. I told you first about that. Okay, so those are the principles. The test levels. Aaron did a very nice job telling you about the component or unit testing, which verifies the functioning of the software items that are separately testable, the little chunks. Integration is the testing of how these pieces work together and how they work with the hardware, or in this example, the file system. So component and integration testing is mostly performed by you, developers. Then we have the system testing that tests the behavior of the whole application, and this is mostly done by the quality assurance team, or the testing team. And the acceptance testing, this is where usually the customer will make sure that the product fulfills their need and expectation. So these are the levels, and we have here the types. The first one is functional testing, is what the system does. It's typically described in a requirement specification, or in Agile is the user stories. ILIT is usability, reliability, portability, load testing, stress testing, and so on. Next one is structural testing, or we call it white box. Code coverage, statement coverage, decision. Again, this is mostly done by the developers. And the last one is confirmation and regression testing. This is related to change in software, fixes of bugs, new features added. Again, Aaron mentioned this. In Agile, the regression testing is a big part, because this is based on constant releases, at least once a day, right? And to make sure that this works well, that we need to do regression testing. And this heavily uses unit testing and other types of automated testing. How many automated tests you think Google runs daily? 75 million. Yeah. Okay. The next slide, I'm gonna let you study it if you want. This is a graph created by one of the guys that signed the Agile Manifesto, and it puts together different types of testing as they face the business side, the development part. What is Scrum? It's a framework, a development framework, a project development framework, where Scrum teams. So you have this frequent daily meetings. You work in short bursts that are called sprints. Usually, a sprint is 2 to 3 weeks. And the mantra in Scrum is inspect and adapt. And probably at the end of the sprint, you have a retrospective.
Retrospective is done Monday.
Exactly. Cool. So you'll know what to expect from that. Another example, FBI went Agile. What happened here? After 9/11, FBI decided to create a platform where all the information about terrorists from different government agencies is put together for obvious reasons. They spent about $100 million on a project. It wasn't going anywhere. They scrapped, and they started another one. This one, after about 3 years, it was a little over $400 million, and they asked another government agency to do an evaluation of how much money they still have to put into this to get it work. And the estimate was about $360 million more. So they fired the contractor. They hired an Agile chief information officer, and they Agile CTO, and with about 55 employees in 1 year and $30 million using Agile, they made the project work. They broke the whole thing in 600 plus user stories and worked in 3-week sprints over a year, and had it done. And well, this is a nice story. If you want to check another success stories, Spotify, they have to compete with iTunes. They use Agile. Obviously, they don't have the resources that iTunes have. And, right. Real quick, the roles in the Scrum is the product owner. If you've been doing that, well, it depends what you're developing there. But the product owner is very close to the business needs, and they know what the priorities are, and they are the voice of the client mostly. The Scrum Master, this people make this confusion. The Scrum Master is not the boss. This is a pre-level. Is not a hierarchy actually, but it should be an expert and advisor, a facilitator, and the organizer of the Scrum. And the team member is responsible for completing the user stories. Basically, is responsible of working in team and help the team do the job, not doing their job. You already worked with user stories, right? This is the mostly recommended way of describing user stories. As a registered user, as a type of user, I want to do something. I want to log in so I can get something. Access, in this case, subscriber-only content. Okay, I'm not going to go into too much into this. This is the tool that we are using. It's called Jira. This is an example of the product backlog where the user stories are organized by importance. So, say in a 3-week sprint, you're done. You didn't evaluate the effort correctly, and luckily you're done ahead of the time. You can pull stories from the backlog, and because they are already ordered, you're going to get the most important first. This is the sprint backlog, burnout chart. Task board, we've already seen this. This is organized by swim lanes. This circles are actually team members. The sprint cycle, you're familiar with it. It's a you have a sprint planning meeting of 1 or 2 hours per week of development, so it can go up to 6 hours if you have a 3-week sprint. Right? The daily scrums. Some teams prefer to do it, let's say, stand up to make it uncomfortable, so it doesn't take a lot of time. Then you can have a story time or backlog grooming of 1 hour per week during the sprint review, and the retrospective. This is the procedure that we are using at B3 for bug reporting, and what I wanted you to take from here is this is a formalized process. There are roles, and it's not just a ping pong of bugs from one another. And the last thing is to close the circle. We should have a customer reported defects system where we collect all this information from the customer to see how, and this is very useful to give us an idea of how we performed in our quality assurance activities. People don't really realize this. I mean, as a developer, you think, okay, that the testers are going to get it. They may or may not. So you really have to put some effort and.
Plug it in. It's going to say, hey, I see you put in a new device, and it's going to load in the appropriate drivers. You'll notice that this scanner build. Whoa. Moving right along. That must be why we're not shipping Windows 98. Absolutely. Absolutely.